Okay, the last thing we're going to talk about is functions as equations. So we're going to discuss something called function notation. And it's just another way of writing an equation. So function notation defines the range or the output of the function by using any value of the domain or input, which we call x. So if an equation is a function, then we can substitute y with f of x. So it's f parentheses x parentheses, and the way we pronounce that is f of x. So I just mentioned if an equation is a function, then we can do this. We're going to discuss more about functions later on in the semester, but for now, we're just going to assume it's a function. All linear equations are functions except vertical lines. That's the only ones that aren't. So as we were just reviewing linear today, most linear equations are also functions. So if I have an equation y equals 3x plus 1, I can change that into f of x equals 3x plus 1. And this is a function notation, which is basically the same thing. We can still graph it. Instead of the y-axis, we're going to have an f of x axis. To find the value of a function at a given x value, what we're going to do is we substitute the x value into the equation and reduce or evaluate. This is the word we like to use in math. So let's say I have f of x equals 2x minus 3, and I am trying to find f of 5. So do you see that this 5 replaced the x in f of x? So instead of f of x, we have f of 5. So if the 5 is replacing the x, well then the 5 needs to replace all x's. So f of 5 is equal to 2 times x minus 3. But instead of x, I'm going to replace x with 5. And now all I need to do is simply evaluate. 2 times 5 is 10, and 10 minus 3 is 7. So f of 5 is equal to 7. Now thinking as an ordered pair, if I plugged in 5 and got out 7, the f of 5 equals 7 basically gives me the ordered pair, both 5 and 7. So it's kind of a more complete picture. Instead of just plugging in 5 and the answer is 7, when you write f of 5, you can see that you did plug in 5 and you got out 7. Let's do this again. F of negative 2. Notice negative 2 is in place of the x. So every time I see an x, I'm going to take x out and replace it with negative 2. So this is negative 4 minus 3, which is negative 7. So f of negative 2 is equal to negative 7. If I were thinking of that as a point, I could write that point as negative 2 comma negative 7. And our last one, f of 0. Notice the 0 is in place of the x. So every time I see an x, I'm going to replace it with a 0. That gets me 2 times 0, which is 0, minus 3. And 0 minus 3 is negative 3. So f of 0 is equal to negative 3. If I were to put that in an ordered pair, I'd get 0 comma negative 3. Now, I'm not asking you to put them in ordered pair. I'm just trying to relate it back to all of the other things that we've already done in this lesson. And then the last thing we have is a word problem in function notation. The total cost for a taco shop to produce 100 breakfast tacos is $76, while the total cost to produce 120 breakfast tacos is $84. Let y represent the total cost for x breakfast tacos. Assume that a straight line can approximate the data. So if we have x breakfast tacos, comma y total cost, well, if I have 100 breakfast tacos and that costs $76 for the little taco shop to make, then I have an ordered pair. Over here I have 120 breakfast tacos and that is going to cost $84. So when you're thinking of making breakfast tacos, you have to pay for the your little taco stand, you also have to pay for the lights and the energy, the electricity, and maybe gas that you're using to use the stove to make your breakfast tacos, right? Plus, you have to pay for the ingredients. So our slope is going to be like price per taco, okay? But additionally, you have to pay the overhead of just running your shop. So that is going to be like your y-intercept. So step 1, it says find and interpret the slope of the cost line. So we have this is x, this is y, and this is x1 and y1, and this is x2 and y2. So the slope is going to be 84 minus 76 over 120 minus 100, which reduces to 8 over 20, and 8/20 reduces to 2/5. Okay, so my slope is 2/5. 2/5 is very helpful when you're graphing because you have a rise and a run, but 2/5 doesn't really help us to interpret what this slope means. So if I have m equals 2/5 and I can take 2/5 and type it in my calculator, that gives me 0.4. And I'm going to add an extra 0 there so we can think about it in terms of money. So if my rate of change is 40 cents, what does that mean for my tacos? It means we're going to have 40 cents per taco for the cost. It's going to cost 40 cents for this taco shop to make each additional breakfast taco. Probably buying in bulk there to get the cost down so much. So that's what that means, okay? Now you could also use 2/5 or 0.40. In this case, when we're talking about money, probably 0.40 may make a little bit more sense. Determine the linear equation that fits the model. Write the equation in slope-intercept form. Well, what am I given? I have 2 points and I have a slope. So I can use point-slope form with either the x1, y1 or x2, y2, whichever point I like better. So I have y minus y1 equals m parentheses x minus x1. Y minus my y1 is 76 equals 2/5, which is my m, parentheses x minus 100. So I'm going to distribute here 2/5 x minus 2/5 times 100. 2/5 can also be 0.4, right? So if I have 0.40 multiplied by 100, that just moves the decimal over 2 places, and that's 40. So that's going to be minus 40 here. And we have y minus 76. And then I'm going to add 76 to both sides so that I can get my y by itself. So I have y equals 2/5 or 0.4 if that makes you happier, x plus 36. All right, so that's my equation. So what is the point? The 36, that's my y-intercept. So this is going to be like $36 for overhead cost. Even before I start making any breakfast tacos that morning, I have to pay all the bills. So that's kind of like your bills per day, and your slope is your rate per taco. Okay? Additionally, I could have written this in function notation. F of x equals 2/5 x plus 36. That might help me for future problems down here. So for part C, it says use your answer from part B to determine the approximate cost of 180 breakfast tacos. Okay, so if I'm trying to find f of 180 tacos, I'm going to simply just plug in 180 for x. So this is what 0.4, we've already said that's 0.4, so I have to take 180 times 0.4. So that's 72 plus 36, which gets me 108. So that means it's going to cost $108 if I'm trying to make 180 breakfast tacos that day. All right, so this concludes our lesson on a review of linear functions and linear equations.